Okay, so for my final lecture, I'm going to talk about meta-empirical theory assessment, and the presentation is going to be organized roughly around these points. Some of them are a little interleaved, actually. But I'll first talk about normal empirical theory assessment and the problem of underdetermination in a pretty standard way, and then motivate non-empirical theory assessment from that, and begin to introduce the idea of meta-empirical theory assessment as something distinct from the more general category of non-empirical theory assessment. Then I'll discuss the three main meta-empirical arguments that David has introduced and discussed, talk about how it's applied in practice in a few cases, and then show how meta-empirical evidence and theory assessment plays a role in a variety of familiar kinds of scientific reasoning, from empirical confirmation to something that I've discussed in a paper of mine on eliminative reasoning. Okay, so nowadays when we look at scientific methodology, we find widespread agreement among both scientists and philosophers of science that the fundamental assessment of scientific theories is with respect to experience, observations, experiments, that sort of thing. But observations and experiments of things that fall within the predictive scope of the theory, that's what we regard as evidence for the theory. So, for example, just a simple random example, if we have a theory of general relativity that predicts that massive bodies cause light to bend, then if we find that we observe light bending in the presence of massive bodies, then we can regard that theory as confirmed, perhaps to some degree, if we think of things in a more Bayesian way. Or if we observe light failing to bend in the presence of massive bodies, then we can regard the theory as confirmed or falsified, and maybe also to some degree, right? A familiar kind of idea of empirical confirmation. Now, it's also possible, of course, that a number of theories share the same prediction and are confirmed or disconfirmed by the same evidence. And this, of course, is known as underdetermination of theory by evidence. Okay, it's important to recognize that there's different kinds of underdetermination, though, that have been discussed by philosophers, and also, logically speaking, some that haven't. Okay, so we can distinguish between underdetermination by all available evidence, at some specific time or in some specific context, or underdetermination by all possible evidence, right, that could be conceivably acquired anywhere at the universe at any time. Okay. Also, we can distinguish between underdetermination with regard to all logically possible theories, or just with regard to admissible scientific theories within some specific historical or temporal context. Yeah. So, if we think about the kind of discussions we can have about underdetermination in philosophy, we might be interested, for example, because we're interested in the scientific realism debate, we might be worried about underdetermination with respect to all possible evidence, things like that. But for the purposes of actually assessing scientific theories, for scientific purposes, all logical possible theories and all possible evidence are really irrelevant considerations. They can't be used to really motivate any kind of theory choice or something in a specific context. Yeah. And so, for this reason, when philosophers of science think about scientific methodology, they should really just focus on underdetermination, which is conceptually possible in a given historical scenario in science. Right? This might be a historical one if we're interested in atomism around the late 19th or early 20th century. We might be interested in the kind of conceptually possible scientific theories that could be developed at that time, given the evidence that was available at the time. Or if we're interested in quantum gravity, we might be interested in our current circumstances. What sort of theoretically possible theories, conceptually possible theories, I guess I should say, that are possible within the current time, with respect to the evidence that we have available at the present. Okay, so even if we ignore these scientifically irrelevant kinds of theory underdetermination, it's generally expected that scientists will face underdetermination of scientific theories by the available evidence to some extent. Right? So underdetermination is like a real a challenge in scientific methodology. So it doesn't have to be regarded as like a scientific problem, like in the sense that if we have underdetermination, that this causes a problem for science and its progress and so on, especially since we expect it to happen. It's something that has to be accounted for in a way. One role that it may have is just to limit the degree to which a theory can be confirmed. Right? If there's lots of empirically equivalent theories, then we couldn't say that one of them is normally is like much higher confirmed than its competitors. Yeah, unless it has some characteristics that distinguish it anyway. Okay, so because of the presence of underdetermination, philosophers and scientists have proposed means of assessment that go beyond the usual empirical theory assessment as a way of breaking this underdetermination. Okay, so some of these motivations come more from philosophical issues like scientific realism or so, but also, when it's a matter of theory choice, the scientist wants to know which theory is worth accepting or even pursuing, they need some extra empirical means for breaking that underdetermination. And so let's call any of these means non-empirical theory assessment, just to distinguish this kind of theory assessment from the normal kind of theory assessment that I talked about on the first slide, where we use observation and experiments to confirm or disconfirm a theory, where those observations and experiments concern things that fall within a predictive scope of the theories in question. Okay, so one popular approach to non-empirical theory assessment is the assessment of theories on the basis of what are called in philosophical literature theoretical virtues, so things that get discussed in the literature that fall in the category of theoretical virtues are things like simplicity and fertility and beauty. Now, I'm convinced by the critics here, the critics that have pointed out that none of these theoretical virtues have a clear epistemic import. And because of this, insofar as they don't have any epistemic import, we can't use things like simplicity, fertility, and beauty to confirm or disconfirm a theory. They don't give us any reason to trust a theory. They don't even give us a reason to pursue a theory insofar as we regard pursuit worthiness as an epistemic matter. Now, as a merely like practical matter, or maybe because we have other values besides epistemic ones, then we might have things like beauty influencing us. But at best, I think theoretical virtues can have a practical or heuristic value at best, but at worst, they're completely irrelevant to theory assessment, insofar as part of our goals are epistemic in nature. Yeah.
Yeah. Now, of course, maybe this depends a bit on what you call, what you group under certain virtues. If I take, for instance, understandability or transparency, right? So how lucid is it? How clear, how direct can I understand why a certain of you is other things? You could say this is epistemic and not just pragmatic, for instance, right? Sometimes I don't even know where does pragmatic start.
Sure.
So I'm just wondering, in that spirit, right, pursuit business, I would think can often be epistemic with respect to theoretical.
Yeah. I mean, in epistemology literature, there's a lot of discussion about understanding as a kind of distinctive epistemic value. And sure, I think we're both happy to acknowledge that as something that can play a role in pursuit worthiness assessments and so on, but it's slightly separate because the the level of comprehensibility doesn't, in a formulation, we might have a better formulation or a worse formulation of a theory. That doesn't make the theory more true or less true or more viable or less viable. It has something to do with like intelligibility, as you said, or conceivability. So it's a slightly separate matter, but it's an important one, no doubt, for sure. And actually, so Richard and I are developing a paper on pursuit worthiness now, and that is a case we have to consider, but we're setting it aside because that doesn't necessarily play a direct role in whether a theory is viable in some empirical context or not.
Yeah, so I just mean maybe McCoy has a wider conception of what means viable, which is not just about truth.
Yeah,
I'll get to that. It's epistemic and not just...
of course it depends a little bit on what you want to say by epistemic, so we can take a sort of a narrower or wider version, Yeah, I think we do want to potentially recognize, I mean, I do have a paper on scientific progress that distinguishes understanding and knowledge in roughly this way, and acknowledges the importance and the interaction of those two conceptions. But for this kind of discussion, it's really the sort of narrower, epistemic in the sense of something more like, knowledge. But we're for reasons that you'll see, not committed to, the truth of the theory is required for us to, say we know it in a relevant sense. This whole story is pretty contextualized, as you'll see.
Yeah, sorry.
Yeah, well, it's a relevant point for sure. Okay, so so Richard David was motivated primarily by conflicting assessments of string theory in the physics community to develop an alternative framework for thinking about theory assessment. And initially, he described his approach as non-empirical confirmation. And since then, it's sort of backed off from that term and called the approach meta-empirical confirmation and meta-empirical theory assessment, just to acknowledge that there are sort of other approaches to theory assessment that are, in the relevant sense, non-empirical. So from now on, I'll prefer the term meta-empirical theory assessment when talking about David's particular approach. Okay, the starting point for his work published in this book, 2013, I think it is. Although he'd started working on this project, many years earlier. The first paper I think he published on it was 2006. But all that work was eventually sort of packaged together into this book. And the focus there was primarily on string theory, because that's the context in which he developed his ideas about meta-empirical confirmation and theory assessment. But since then, it's spread further into other areas of science, as I'll mention a little bit later. Okay, so one of the primary distinctions to make here is between empirical and meta-empirical evidence. So if we go back to this canonical mode of theory assessment that I began with, empirical confirmation, empirical theory assessment, this is based on the comparison of theoretical predictions with empirical evidence. Now here, empirical evidence denotes evidence that is directly compared with theoretical predictions from the theory that's under assessment. Another way of putting this, that Richard often puts it, is evidence that falls within the scope of the theory, where we mean the explanatory and descriptive scope of the theory, the kind of things that it predicts and explains. That's what we normally consider, scientists and philosophers of science alike consider, empirical evidence. So the kind of evidence that David claims is relevant to theory assessment in science isn't this kind of evidence, because it doesn't fall within the scope of the theory under assessment. Okay, so in the sense of empirical evidence, as understood in this canonical mode of theory assessment, this kind of evidence is not empirical evidence. However, it's a little bit of a terminological issue. Of course, it's evidence in the empirical, in an empirical sense, in a broad empirical sense. It's evidence that we do obtain by empirical means, observation. It's just that it's evidence that's gathered at, shall we say, a meta level at the stage of scientific research process itself. Okay, so that's why from now on I'll be calling this kind of evidence meta-empirical evidence, to clarify that it's distinct from the kind of empirical evidence that plays the main role in the canonical mode of theory assessment. But this whole approach is sort of empirical in the sense that we're going out and acquiring evidence in order to assess theories. It's just that it happens at a different level, okay, as we'll see. All right? So the first argument that has this meta-empirical character, that's also the easiest one to understand, is the no alternatives argument. So the meta-empirical evidence that's the basis of the no alternatives argument is that in a particular theoretical context, the observation that we have is that after a sustained search for theoretical explanations, only one consistent theory has been found. Okay? That's a piece of evidence that we could acquire, right? By just paying attention to the scientific process itself. Scientists are searching for theoretical explanations for some target, and they only find one after some period of time. That's something that we can observe. It's a fact, right? Okay, so how can we explain this fact, though? Like comparing to the empirical case, if we're looking for theoretical explanations of some, empirical observation, right? I think I won't make that analogy at this point. So anyway, let's go back to the piece of evidence that we've acquired here, this meta-empirical one. If we think about explanations for this piece of evidence that we found, one explanation is that scientists just haven't tried hard enough, or they haven't spent enough time on the problem, or maybe the problem is too difficult, right? That's something that we would often naturally expect when we try to explain this meta-empirical fact. But another explanation, and this is the important one for the whole meta-empirical theory assessment paradigm, another explanation is that there are in fact very strict limitations to scientific underdetermination in this context. It's not that it's just hard to find other explanations, or scientists haven't been smart enough, or spent enough time, or whatever. Rather, it's just that there's very few theoretical options that exist that can explain what we want to explain. Okay, so now, I'll talk more about limitations to scientific underdetermination very shortly, but this is an alternative explanation, right? If we imagine that the theory space, as it were, is really constrained, then that would explain why scientists have only found one explanation after searching very hard for them.
So then that means that consistent theory here also means consistent with the available evidence, empirical evidence at that time?
Yeah, I think also self-consistent is also an important part of that, and maybe the more emphasized one, but also, consistent with the available evidence too. Okay, maybe it doesn't have to be very strict, because we could allow that, some evidence has been misinterpreted or so on, but roughly speaking, some sort of consistent theory in a reasonable scientific standard, maybe not a strict logical one. Okay, so in any case, if we can, so these are competing explanations for this meta-empirical observation, but if we can argue that the latter explanation is more credible in some way by, say, eliminating or discrediting this other explanation, then it follows that the theory which has been discovered is in fact more likely to be true on the basis true, or as I'll later say, viable. Okay, I use true in a very loose sense to begin with, okay? On the basis of the observation than it was before the observation was made. Okay, so then this is exactly the kind of thing we would say in the parallel case of empirical confirmation. So that given the parallelism, we could say then, in this case, that the theory is meta-empirically confirmed, right? In more or less just the same way that we would be inclined to say that empirical evidence confirms the theory.
Which is what they get, because in a sense, so we use the word viable now rather than true, right?
Yeah, I haven't gone into that yet, because I have to explain what we want to, why viability is a preferable term to introduce in this kind of method. I'll get there.
No, sorry.
But you can put true, I should have put true in quote marks. Or just start, you've got to start somewhere.
All right, yes, but we will need to talk about that.
We will need to talk about this. And I hope I can clarify the important why David prefers this term viability rather than talking about truth. Okay, so I'm not going to go into this too much, but like on this slide I was saying that given the parallelism between the arguments for meta-empirical confirmation and empirical confirmation, we should think that if we can make arguments like these, successful arguments like these, then we should say that the theory is confirmed. And we also would say the same thing in a parallel case for empirical considerations. But I haven't said anything about what kind of theory of confirmation is in the background here. That's because I think it doesn't matter. Whatever theory of confirmation you prefer, the parallelism will exist. But David usually works with the Bayesian framework and as a way of sort of bolstering the idea that there's genuine confirmation here. David Hartman and Sprenger wrote a paper in 2015 that formalized this no alternatives argument within the Bayesian framework. Okay, so here, just to say very briefly what's going on here is F is here representing the observation of no or few alternatives have been discovered. And that has, I guess I didn't put all the variables in here. Yeah, so this observation F here represents, as I said, the meta-empirical observation that there are few alternatives. D sort of represents these other alternative explanations. It's too difficult. Scientists just haven't worked hard enough, and so on. Y represents this meta-empirical hypothesis that there are, in fact, strong limitations to underdetermination in this context. So F is relevant to both D and Y. If we can eliminate D, that sort of increases our probability or credence in Y, and Y is correlated with the hypothesis or theory T in question that has been found. So, I mean, this is represented in some sort of Bayesian node network sort of thing. I don't want to explain all this because it would take quite a while, I think. But in any case, the point is that you can, as David Hartman and Sprenger showed, represent that this confirmation is confirmation in the standard Bayesian sense. It just happens in a more indirect way. Like normally we just have theory and evidence in the Bayesian framework, but here the confirmation is kind of being mediated indirectly by a meta-level hypothesis, this Y. So it's a little bit different. You have to formalize things that are a little bit different, but still you get probability increase in the normal Bayesian sense with the relevant conditions. Yeah, the observation, the arguments that eliminate D as an explanation for F, thereby leading to an increase in probability of Y, which then influences an increase in probability in T. Okay, so this is just, yeah, if you like the Bayesian approach, then you can understand the no alternatives argument completely in a Bayesian framework. Okay, so now I should talk some about limitations to underdetermination, because this is kind of the basic idea that motivates meta-empirical theory assessment, that there are possibly limitations to underdetermination. And this is, in some ways, I think, philosophically controversial, whether there could be such a thing as limitations to underdetermination. So I want to talk about that. All right. Yeah, so as I said, whether it's a valid form of theory assessment or not completely hinges on this fact that we can obtain meta-empirical evidence, which is evidence of limitations to theory underdetermination, specifically of the scientific kind, not underdetermination with all logically possible theories or anything like this. Okay, so yeah, this obviously depends on whether there are, in fact, limitations to underdetermination, and this, again, is a point where people philosophically might say, no, there can't be such thing as limitations to underdetermination. Okay, so how can we know whether there are limitations to underdetermination? Well, in one sense, the argument would be entirely evidential. So if we acquire pieces of meta-empirical evidence which confirm hypotheses about the existence of limitations to underdetermination, then we have reason to think that there are. That is, if we're in a situation where we have this piece of evidence, F, and we can have arguments that show limitations in D, then the alternative explanation is Y, and so we have then reason to believe that we have reasons to believe this meta-empirical hypothesis Y that says that there are limitations to underdetermination in this context. But that won't necessarily convince anyone, particularly those who believe that more strongly that underdetermination is effectively unlimited. Right? And so I think it is worthwhile to give a more general argument to a sort of, I don't know if you see what I mean, like normally if we give arguments for some hypothesis, the direct argument should convince us, but you might have some sort of meta-level belief that interferes with that. And so I think a more general argument for why there have to be limitations to underdetermination in general is required. Okay, so I found one place in Richard's book where he does give this more kind of general argument, and so I want to talk about this a little bit. I'm not sure just this paragraph can completely elucidate the idea, so I'll say more on the next slide, but just to give his version of this. So he says scientific underdetermination cannot be taken to be entirely unconstrained. There have to be limitations to underdeterminations. Why? Well, if it were, that is, if all imaginable regularity patterns of empirical data could be fitted by fully satisfactory scientific theories, no correct predictions of new phenomena could ever be expected to occur. One would rather be led towards understanding the specific predictions offered by the presently available theory as one accidental pick among an infinite number of theoretically viable options. In this light, it would seem entirely unreasonable to take those predictions seriously. It is a fact, however, that successful predictions of new phenomena do happen frequently in advanced science. Scientific underdetermination thus must be assumed to be limited in some way. That's a pretty quick argument, but yeah, I don't know if it makes sense. So let me try to expand on what Richard says there a little bit. So the basic point, I think, is that unlimited underdetermination would completely undermine the scientific method and make scientific progress entirely irrational. It would just be a matter of random guessing there. But science doesn't seem to be a matter of random guessing, and so there has to be limitations to underdetermination, roughly. So let me go further. So imagine, and this is just pulling off what he said, what I showed on the previous slide. So suppose that scientists have an empirically successful theory at a certain time, right? Yeah, it explains and predicts observations that we have. Now, if underdetermination were unlimited, there would be an infinity of competitor theories that predict the exact same evidence, explain the exact same things, right? Unlimited underdetermination, there are all these theories that do that. But among these theories, an infinity will succeed at the next level of empirical testing, and an infinity will fail. Now, so there's no reason to rationally expect that the arbitrarily chosen present theory among those possible ones will succeed at the next stage. Right? Theories would just be predictively useful because we'd say, well, I mean, it's worked so far, but who knows if it'll succeed tomorrow. Yeah, I have no reason to expect that, right? Because there's all these competitor theories that have said the exact same thing up to the present moment, but diverge arbitrarily at future times. Yeah. But we do trust theories. Why do we do it? Is it because we're completely irrational, or do we have good reason to expect that theories will succeed in the future? Yeah. So the claim here then, the conclusion here really, is that the existence of limitations of the underdetermination is the only way to make rational sense of scientific success. If at each stage of empirical testing underdetermination becomes or is strongly limited, then we can understand how we manage to find successful theories and find that those theories can be further developed into successful theories in the future. Obviously, it's not a purely logical process, but limitations to underdetermination allow us to sort of, make rational expectations about our future theory, both their predictive success and the future development of successor theories at other stages of development. Okay, I can pause there if anyone has a question about this. This is sort of the central general argument I would want to make here.
Clarification, the person that he or you guys are addressing also is thinking of not the logically possible kind of space, but rather.
I mean, they could be. That's probably where the basic motivation comes from.
Okay.
But yeah, we would like to say, yeah, even in a specific context, someone might imagine that underdetermination is effectively unlimited too.
Yeah, right. So you're addressing both the person who thinks, so both someone who's thinking of the broad, so to speak, notion of underdetermination and the narrow one. I think one thing that's at the moment not to me, but this is thinking out loud actually, is I'm thinking, I guess I'm a little surprised at how strong this argument is, because I thought it was more like in some contexts of science this can happen, and now it sounds more like there are always the limits to underdetermination, even in the narrow sense. Maybe this is also clarificating a misunderstanding.
Yeah, I mean, no, not necessarily. I mean, we can find ourselves in contexts where underdetermination is effectively unlimited.
Okay.
Yeah, but if it's always effectively unlimited, then we would never make any progress at all, is the argument.
Okay, so the opponent is saying it's always unlimited.
Yeah, and we're saying it's not always, and it hasn't been in important cases in scientific history. Otherwise, we wouldn't have things like quantum mechanics, basically.
So this is just saying in some cases there are limits.
Yeah, there have to be some for scientific progress to make sense.
But, I mean, like, this is not strong enough to deny in the relevant case.
Sorry?
It is not strong enough to argue that there are actually some cases in which you have you can apply the Bayesian reasoning to meta-empirical evidence. No? Like from this argument, like my question is like how, like from this argument against unlimited underdetermination, you can actually jump to the conclusion that in specific cases you can use limited underdetermination as a meta-empirical.
Well, so that, I mean, you have to look at individual cases. This is just a general argument that there has to be sometimes limitations to underdetermination, otherwise we can't make sense of scientific progress. If you say, okay, fine, I can accept that, then to apply it, you need to make specific arguments. You need to do what we normally do. You have to go out, acquire evidence, make the arguments, and see whether they're good or not.
Yeah,
sure.
So it was just to say that the existence of limited underdetermination doesn't mean underdetermination doesn't mean that you can actually use it
Right.
for revealing the meta.
Yeah, maybe you can, maybe you can't. You have to go out and see. Yeah, it depends. Yeah, this is very contextual in that way. But I wanted to make the general argument because I think a lot of philosophers of science just automatically think that, wow, it's so easy to achieve alternative theories, and so theory under determination just must be ubiquitous. And we're saying, well, it can't be all the time. Yeah, I mean, this is a debate people have in underdetermination literature. Some people like Norton say, oh, it's got to be limited because it's really hard to ever find alternative theories. But then other people, I think, motivated more by the idea of in principle underdetermination. It's so easy to just arbitrarily, syntactically create alternative theories, and so underdetermination must always be possible. But I think these arguments often kind of are slipping between different conceptions of underdetermination and always working with the same conception of underdetermination.
How much does it regulate to realism? I mean, obviously, for the realist, there's always a tendency to say there's one true story if you just capture it well enough. And for the anti-realist, you would say, now you have all these kind of tools, right, and all these possibilities. And then I guess it depends also what you mean by tools, and once this, I'm just wondering, how do you really cut down the amount of options? This freedom is normally by saying you somehow have to latch onto the world and see something. You would do this theoretical wishes, I suppose, but or maybe not. But some people might do this theoretical wish, but then only in wish that they latch onto the world, you would normally apply this constraint possibility. Yeah, I'm just wondering, do you see
I will talk a little bit about truth and realism a little bit later. But I think the point of this is that it's much more sort of oriented towards scientific practice, where considerations of scientific realism don't really matter for making decisions about the scientific research progress. We're trying to figure out what theories to pursue and trust and so on, and truth doesn't really matter for that purpose. All of this is very much contextualized in that way. So in the last part of Richard's book, he does discuss realism a little bit, because you might think that if we have a final theory of everything, like string theory, that's confirmed, say, by Meta-empirical arguments, then you have some reason to be a realist about string theory because it's a final theory. So he discusses that issue in the end, but generally, realism seems premature in most of these cases. If we try to bring truth in, truth is a kind of final theory consideration, an context-free kind of concept, but it's just not applicable really to very contextualized assessments. We don't need to bring in truth considerations in order to decide whether a theory is trustworthy or pursuit-worthy or things like this.
Yeah, this is really just a modest observational way, pairing of saying that it would be really hard to do if there were all these options, and at the same time we observe we can actually do this, right? So, and then of course leaves free what do we really mean by working by scientific theories, right? So, and if you would expand doing scientific theorizing by methods of AI, let's say, with deep nets, but by now we would think that actually many alternatives, including gravity, model the same system, input, output, with different neural nets or something like this, right? And so if we just stretch our notion of scientific theory, we might actually get more and more towards this unlimited individual. but often we work with sort of human-made sense of theory, which somehow is linked to understandability, right? And explanation, and then there's always a lot of kind of aspects that seem to be about, maybe something was real or maybe
Well, I mean, one thing that matters for this is, again, like emphasizing the contextuality of it. A lot of theories that maybe, an AI could develop wouldn't be distinguishable with other theories within a specific empirical context.
Right.
And so it wouldn't really count as an alternative then.
Yeah. I see.
So they have to make sort of distinctive predictions within a particular empirical context to really count as differences.
Sorry, I think that was important. Can you just, I want to make sure that I didn't miss that. Did I hear that right, that something only counts as an alternative that it makes slightly different empirical predictions?
Within a specific context. Yeah, this also is connected to the viability idea. I'll talk about it. Yeah, but that's true, yeah.
Just a very brief, just on this issue we were talking about earlier, I'm still, I think, wondering about, it sounds to me as though the general argument should say that the limitation to underdetermination in question happens precisely in cases where scientific progress happens. Whereas I expected kind of the opposite to be the case, because, like, for example, with string theory, I guess, it was more, it's not a paradigm case of, we are making scientific progress now, or,
I mean, we can also think, like, when we discover that underdetermination in some context is relatively unlimited, that's still some progress. We've learned something about the theoretical context. And so there's valuable progressive things we can do in that context there as well. So I don't want to limit scientific progress to just like the elimination of theories where we therefore, only when we trust a theory do we say we've made progress. I mean, there's a lot of things we can do, I think, that contribute to scientific progress. Maybe this is a way we want to, some people want to distinguish between what constitutes scientific progress and contributes to it. Maybe we make some differences there, but I don't want to necessarily sort of say this is what scientific progress is.
But so in any case, you do mean for the cases in which this applies to match up with the case in which we want to supply more specific arguments to apply the basic.
Okay.
Sorry.
Oh, sorry.
So the point is that underdetermination. When we say that underdetermination is, so to be able to say that underdetermination is limited, like we need already to have an account of like how the scientific method works and what counts as evidence within the scientific method.
Yeah, exactly. Yeah, so we need evidence. We need to identify what kinds of evidence are relevant to arguments for limitations to underdetermination. So the no alternatives one is one example of that. Because it's clear that one possible explanation is a limitation to underdetermination. It would explain that observation that we've only found one. But I have two more examples. Maybe there's others. Richard and I have kind of not really thought about this in a great amount of detail, I think, about what other alternatives there are. But maybe there are just these three, maybe there are more. I mean, it's an interesting question to see what kinds of meta-empirical evidence are there that would be explained by limitations to underdetermination. That's the really general question. Exactly. Yeah. Okay, so right, and this is I speculate here a little bit that intuitions of underdetermination is rampant no matter the context, reliance on intuitions that have been tutored by general logic. A lot of, I think, philosophers learn a lot of logic and think in a very logical way, but that can mislead you, I think, sometimes, an overly logical approach to thinking about scientific method. Scientific method is precisely a kind of practice. Science is a practice that isn't like completely logic built. Like something like mathematics is closer to that, but it also isn't really purely a logical practice. So, for example, like if we represent scientific theories as sets of sentences, as in the kind of syntactic way of thinking about theories, yeah, it seems clear that even with the additional requirement that the theory entailed the given empirical facts, there's an infinity of theories of every conceivable kind, right? You could just add more sentences of various kinds and more complicated stories, connecting sentences together, more theoretical, blah, blah, blah. Yeah, and so it seems, look, there's all kinds of possible theories. But I think, yeah, this is starting to point towards the role of truth in all of this. Like this way of thinking also, unlimited underdetermination might tacitly be dependent on a background commitment to some kind of correspondence theory of truth. And this is something you find empiricists and realists alike advocating, like certain kinds of empiricists, like von Fossen, for example. So that, in the end, we're always thinking like, okay, a theory has to correspond to the world in some way. There's a lot of ways the world could be, so we don't know what it is. So there has to be, quite a lot of possible underdetermination, even if we try to constrain underdetermination in various ways. Like I talked about earlier, like by saying, well, maybe just in a specific context, but still in a specific context, it seems like we can create any number of theories. Yeah, so I feel like, yeah, this logical training sort of puts a certain perspective on how to think about theories and progress and scientific method and so on that I think sort of resonates in certain ways. Okay, I think if we pay more attention to scientific practice, I think we would generally be led to think that underdetermination depends on context quite a lot. Personally, I feel like this is like one of the main lessons of the long historical debate over the problem of induction. The problem of induction is really only solved, as it were, by recognizing the contextuality of induction. Induction is not a sort of just a logical procedure. It has to be thought of as a more practice, context-based kind of thing. Anyway, that's just a kind of like speculation about where some of these intuitions are coming from that favor the rampant underdetermination general thesis. Okay? Yeah, so anyway, I'm starting emphasizing this already because it connects with the role that truth plays in all of this as well. Okay, so let me move on to the second argument that Richard gives for a meta-empirical hypothesis about limitations to underdetermination. So the second one is, he calls unexpected explanatory coherence, which for short he abbreviates as UEA. So this argument depends on a different meta-empirical observation. That's the observation that a theory designed to solve a certain explanatory or conceptual problem also solves an apparently independent one. So why there are two here is because it's really no surprise that a theory aiming to solve a certain problem does solve it. Okay, maybe it takes some time, it could be hard or so on, but if we try to solve a problem, it's not by itself so surprising that we're able to do it. But it becomes surprising when the solving of the one problem leads to the solving of a seemingly unrelated one. Right? So if underdetermination were rampant, then it's very unlikely that a theory developed to solve one problem also solves another, just sort of a priori, as it were. Like think of an unlimited space of theories, you're trying to solve one explanatory problem, you find a solution. It seems much more likely that a theory that solves one problem doesn't solve this other one, right? So if underdetermination is significantly limited in the context, however, then it seems much more likely that any discovered theory will be explanatory adequate in that context. So, I mean, you could sort of suggest this by drawing some Venn diagrams or something like this. Here's the space of theories. If we have one theory solving a set of theories that solve one problem, and a set of theories solving another problem, it's relatively unlikely for a theory to fall into that overlap. So when we discover a theory that does solve both problems, that suggests that actually the space of theories has to be quite limited for that to happen, to make it likely that that would happen. Whereas if underdetermination were really unlimited, we would think the overlap of those theories is negligible, so it would be a lucky guess, roughly speaking. Okay? So, even if we accepted the possibility that underdetermination is quite limited in a given context, there are very obvious defeaters to both of these first two meta-empirical arguments. These defeaters would undermine the confirmatory value of these meta-empirical observations, the observations that lie at the base of these arguments. So we already discussed the ones for the no alternative argument. Scientists haven't adequately explored the space of alternative theories due to ability, time, resources spent, and so on. Or maybe the problem is extremely difficult, finding explanatory solutions, and so on. Right? These are kind of relevant defeaters to a meta-empirical argument that suggests the limitations to underdetermination. Similarly, for the UEA, there are obvious defeaters too, alternative explanations of the meta-empirical observation. So maybe the explanations are not as independent as they seem. We think, wow, we solved this problem, we've solved this other one that strikes us as unrelated, but further research may show that those are intimately related problems, and so it's no surprise actually that we solved both of them. Okay, and maybe you can think of other ones too, right? There's always going to be a list of defeaters that are relevant, and the meta-empirical arguments are only successful insofar as you can overcome these defeaters. Now, if you can make both of these arguments in a given theoretical context, you'll find that they're mutually supporting because they have different sets of defeaters. That means if this argument is successful, it supports the meta-empirical hypothesis, this argument is successful, supports the meta-empirical hypothesis. The fact that they're both successful means that these defeaters must be relatively weaker for each one because they're different sets of defeaters. Right, so each independently motivates the conclusion of their limitations to underdetermination in that context. That weakens the argument's defeater and therefore strengthens. I mean, this is just a general thing about arguments, right? If you have two independent arguments for a conclusion and both of them are good arguments, then you don't have to worry much less about the defeaters to those individual arguments. So there's a kind of like a concordance effect or coherence in the arguments. Nevertheless, I mean, it's still not very quantitative to speak in this way. It might be that both the defeaters are valid for each one, right? And so it's still possible that if you only have a no alternatives argument and an unexpected explanatory coherence argument, it could be still a relatively weak argument. So Richard thinks that a third argument really is crucial for the success of those first two arguments. And this third argument he calls the meta-inductive argument, or MIA for short. This argument is based on the meta-empirical observation that a particular research paradigm has had historical success in solving the conceptual and empirical problems that it states. Okay? So a track record of success by itself suggests strong limitations to underdetermination in the research context of the paradigm. So it is a meta-empirical argument in its own right. Right? So rampant underdetermination would make a string of successes in some theoretical field a matter of luck. Right? So if we do find success, that suggests that there are sufficient limitations to underdetermination that we are making progress. Okay? If there are limitations to, yeah, right, exactly, makes a string of successes considerably more probable. As the theoretical, one way of putting this would be to say that the theoretical paradigm is well adapted to a particular scientific context. Yeah, I don't know if this is not an analogy I've ever talked about with anyone, but I wonder if it's relevant. You know, I can think of when I did computer science, there's all kinds of search algorithms that you can use, and one popular one is kind of like a randomized hill climbing kind of thing. And you could think of it analogously to this, if we were just to pick random places, if there's just a few hills in the space of theories that constitute successful theories, if we just sort of randomly start somewhere, we're not very likely to find much success. It could be just a plateau or something like this. But once we're on a hill, we have reason to think that we're on the right track. Yeah, it's something like this, I think, is how we might think about it. And maybe that success will eventually get limited. You'll reach the top of the hill and you might have to start somewhere else completely. Classical physics seemed to be going up a very good hill, but there were some anomalies or so, and we had to completely change paradigms in order to get back on track, as it were. Okay, so a couple comments about the meta-inductive argument. Some I think misunderstandings in the first place here, and second some criticisms that are relevant to the meta-inductive argument. So Karen Carler talks about meta-empirical arguments in a 2021 paper, and this is what she says about it. This is her gloss on the MIA. she says, MI holds that credence in a new theory is increased by the theory's employment of particular features of our current best theories. We know that these current theories are successful, and so we have reason to believe that a new theory that also uses these known features and techniques is itself likely to be successful. I think Crowther might be failing to appreciate how contextual the meta-inductive inference is here, because her example, I think, after saying this, is something like background independence. And originally I had this, but so Richard persuaded me not to talk about background independence because it's a little more complicated of a case. So the example he gave is that, well, if MIA just worked like what Crowther says here, then the fact that large extra dimensions were not found below the electroweak scale and so on, there would be no implication for whether extra dimensions, sorry, I'm misreading it, or maybe I miswrote it, but the point is, like, we can't think of the meta-inductive argument as like just a naive inductive inference from past success to future success. Yeah, a future rule, it's not just a future rule resemble the past inductive inference applied to theory. That's, I think, thinking of things from too much of a logical point of view. And we know that doesn't work. Induction is not justified by the success of past things, right? It's much more contextual than that. So the success of the argument really depends on finding contexts where meta-empirical argumentation is made viable. And so, yeah, I think we can easily misinterpret what MIA is. It's a different kind of argument entirely from just a naive inductive inference from past to future success. It's not that.
Would you mind going back to the just for a moment, just to let it sink in? I was going to look at it.
Well, so, I mean, I could put it this way. Like, you could just read this, like I said, as an inductive argument. Our theory has been successful, it has these features, those features are likely to be successful in the past. That's not what it is at all, because you're not thinking of things when you make that inference in terms of whether there are limitations to underdetermination or not. Does this observation constitute an argument for limitations to underdetermination or not? If you can make an argument for that, then it's an MIA kind of argument or one of the other ones. But if you can't have a viable argument for limitations to underdetermination, it's not a meta-inductive argument or anything like that. Okay.
I think I just have a clarification question. Sorry. What Karen Crowther said was about the viability, or something about a new theory based on old theories.
Right.
I mean, maybe this is ultimately the matter, but I thought I didn't know that the previous slide was about moving to a new theory. I thought it was. It
is not necessarily, but it is also. So, I mean, like the kind of cases that Richard discusses in the book are moving from, say, like standard model of particle physics to string theory or something like that. Okay, maybe you could describe that as a change in models or change in theories, whatever. But yeah, there is a change there. But the meta-inductive argument is also relevant for our understanding of the confirmatory value of current theories too, as I'll talk about towards the end of the presentation. But I mean, a lot of the contexts where meta-empirical arguments are relevant are cases where we don't have any empirical evidence for the theories we want to develop. And in that case, we are generally thinking of a theory change.
Okay, so given that it's also supposed to apply to that, I can better understand how one might arrive at this gloss. So the idea is, since Richard says that the success of the paradigm somehow suggests limitations of indetermination, she thinks that what he's saying is, there are some features of the old theories that because the new theory retains those, that's why we have a high credence in it. But you're saying that's too simplistic.
It's again, the background of independence is maybe like a more complicated case, but I mean, similar ones, a lot of programs in quantum gravity are motivated by the success of general relativity, but I don't know. I'm with Richard on this, that we think a lot of features of general relativity don't suggest that there are strong limitations to underdetermination in the future of that theory that would suggest that those features need to be preserved. Maybe they will, maybe they won't. We just don't have like a long track record of theories that would suggest that a successor theory that has very different characteristics would preserve those ones. Maybe they do, maybe they don't. It's just hard to say, I think. Right? We're trying to transition to a quantum theory from this classical field theory that works for like large-scale structure or something like that. I don't know. I don't see how you can say that the success of general relativity indicates anything about this new context of theory development. I feel like that's a much harder. Maybe you could. I mean, like people involved in this should try to make those arguments. But I mean, I would say, yeah. If you think you just need to satisfy something like this in order to make the meta-inductive argument, I'd say no. If you think there is, though, a meta-inductive argument, then you need to identify how that evidence suggests that there's limitations to underdetermination. You have to do the whole thing, basically. You just can't assume that it's an inductive inference, like just a jumping from success to future success. That's obviously wrong. Just judging from the history of science, we have loads of places where that inductive inference would fail miserably, like going from classical physics to quantum physics. If everyone said, well, classical physics has worked really well, so future physics has to be classical, that would just be wrong.
So, to me, I don't understand the point here on this slide. It sounds as if Mia is constructed just to make string theory look good and everything look bad, because there's something that string theory gets right, is in the right way, sort of restricts future possibilities or future underdetermination, whereas other ways of trying to extend physics do not do that. And I just don't see why principles of GR wouldn't work in just the same way and be extendable to quantum gravity in the way that string theory extrapolates other principles into
then I think
scales.
but I think our preference would be to try to make these arguments then.
People act why background independence is important.
Right, but via the whole machinery of it to show that there are limitations to underdetermination. If you have a compelling argument that there are limitations to underdetermination, then the arguments work. But if not, then not. That's the problem. But this is the problem. I think we find, like, if you just say past success, future success, that's not really using the concept. Yeah.
Isn't any principle restricting underdetermination? So, no, of course it restricts quite severely future theories, because we claim that they have to be background independent. Right, but that rules out a lot of theories.
This is working a lot like empirical confirmation, I think, though. Like if we, the way empirical confirmation works, especially for like novel predictions, is we don't know what the outcome will be. We go get a piece of evidence and we learn something from getting that piece of evidence. Similarly here, if we just sort of put restrictions on what the theories are, like we assume using general principles, like whether there has to be singularity resolution, you're right, that limits underdetermination, but that's sort of by sticking it in by hand. This approach is focused, it's an empiricist approach in a lot of ways. Like go out and get evidence by making meta-empirical observations and then try to understand whether you can use that evidence as a basis for making arguments about the truth of a meta-level hypothesis about limitations to underdetermination. If you can do that, then the arguments are great. Obviously people are going to, this requires interpretation, obviously, and there's going to be disagreements between people about the strength of these arguments, but that's fine. That's part of doing science, I think, is having disagreements about how strong these arguments are. But our point of view is that we should be trying to make arguments like this and assessing arguments and theories on this basis, rather than on the basis of what principles we think are plausible or not. That's just guessing, I think.
Right, but we are making a meta-empirical argument on the basis of, empirical success of these principles.
But how strong is that? And how much is it? How much is it projectable to future empirical contexts? That matters.
Yeah, exactly, of course it does. But it's always going to be, for anybody, If you make inductions, you make a bet on the future will resemble the past. At the end of the day, that's what it is. Because you extend, you go beyond the tested domains, and you make an argument that the way in which you make this extension is based on methods, on principles, on techniques, or whatever that have been successful, empirically successful, in more limited or more restricted or prior domains of application. Everybody's doing that. I don't see
But there's a difference between good inductive arguments and bad ones.
Sure.
And it's hard to make that assessment, so we try to propose an independent way of checking whether the induction is good or not by trying to find some way to constrain it. Yeah, so that if you just make a flat-footed inductive inference, we can say, like, you have given us no reason to really trust whether that's a good inductive inference or not. But if you can make an evidence-based argument that the inductive inference is a good one along these lines, then we think, yeah, this framework gives you some better handle on whether your inductive inferences are good, projectable, and so on.
Okay, I guess I don't see yet what exactly that criteria means to determine whether the inductive inference is a good one or not.
It follows, I mean, we think these three arguments are distinctive because they are arguments that sort of can naturally be understood as being explained by limitations to underdetermination. Yeah. And so I think, if the kind of arguments you have in mind can be interpreted within this framework, then that makes them discussable by people involved. If you just say, though, like, well, it's worked in the past, it works in the future, we just don't have any framework for critically discussing the strength of those arguments. So that's why we prefer having a framework for structuring the discourse around, whether we have good reason to trust some theoretical posit or not.
And what kind of framework would that be?
Yeah, it's not exactly a logical framework. It's a really, I think, kind of based on probabilistic thinking. But it's like we think this is scientific reasoning that's sufficiently objective to allow participants to discuss. I mean, if we don't have something like this, then what happens is people try to talk about things in terms of these kinds of things. Oh, it's a beautiful theory, it's a simple theory, but these things are clearly not connected with scientific success, or at least that's what we would argue. So like those aren't very good arguments for motivating a theory. I mean, rhetorically or maybe psychologically they are, but we think that the success of science indicates that scientific method works, and so we need a framework for understanding how scientific success happens, and the point that this is just a way of rationalizing it in a framework that makes sense.
I'm with you about the law versus scientific underdetermination. Let's rule out these other theoretical approaches and so on and so forth. So all this is that's not the point. But what is it that somehow makes string theory respectable or succeed this Mia argument, whereas background independence does not? What is it that string theorists do more than just say, here are methods and our principles that they've used very well in the past, so let's extend them?
Mm-hmm.
What do they more than that? I don't see what more than that they do at the end of the day.
I mean, this is not really a good question for me because I'm not an expert on string theory.
Right, okay, that's my question. This is what I don't get. I mean, of course they do that. I think, any good scientist is trying to argue that case. And then you negotiate that. I agree, this is then scientific work. That's their job to discuss this. But I fail to see how people starting out from GR are failing in some way to do that, whereas people starting out from high energy particle physics succeed. That's mysterious to me, to be honest.
I think this is probably a good topic for discussion. rather than right now. So let's pick this up. I mean, there's not a whole lot I can say because I'm certainly not an expert in quantum gravity. So it's a little hard. I can say what Richard says. I got that on the slide coming up very soon. But you've seen this before, so that's not going to move you very much, I think. But we can try to discuss it later.
Just for clarification, not for discussion, maybe just for clarification. So in a way, it would be fine if someone said, "Oh, background independence kind of served as a, say, constraint in developing relativity, and then later relativity was shown to be confirmed. And now we go to something which is also the research program of relativity, it's a new gravity, and there we can then make this case. Yeah, in the past, somehow having only background independence, that's the confirmation, so gravity only shows background independence, so well, it's somehow expectable. I mean, it's more likely than before with this argument that we can think this theory to be true or adequate or viable, right? And then the kind of naive thing we don't like is if you just says, oh, GR has background independence, gravity has background independence, GR is true, so gravity is true, right? So you want this kind of Mia narrative in between. And I'm just wondering how much this thing depends on, when did you discover open? Why does it really matter so much that you knew about background independence before you knew that this was confirmed? I mean, this kind of order of evidence and
I think we should go on because this also hooks up with the role of meta-empirical arguments in empirical confirmation too.
Okay.
And there is a kind of a time ordering thing like you're saying. I think. Yeah. So let me say what I have to say there, and then see if that does enough for you.
Sorry,
Yeah.
Another clarificatory question on exactly this space which you can apply these meta-induction arguments. In the sense of would you agree that a less controversial example would be general relativity and Mond, modify Newton and Planck's, and you can say oh, general relativity has a good history of success, of prediction, so in this sense we can apply the meta-inductive argument to see that it's perfect.
Well, I don't know what I would say in that case. So Siska de Berdemacher and Richard wrote a paper about this, but more about whether there were meta-empirical arguments in favor of Mond that would strengthen it, and I think their conclusion is that no, it's quite weak. But I think it's better to talk about specific cases maybe after a discussion, I think, honestly, because I'm not an expert enough in every. I mean, because it depends a lot on the knowledge of the practitioners. I think to make these arguments, I could tell you what I think, but I mean, I'm not researching on these things, so I'm not sure my arguments would be particularly good. So
okay. I just understand whether it was based on the kind of history of success. GR is
I know, I understand your concern, but let's discuss that, I think. Yeah. Okay. I think I already mentioned this a little bit, but in Richard's view, the meta-inductive argument is crucial for grounding the other two meta-empirical arguments, because even though if in a circumstance where you have both arguments, that makes the meta-empirical hypothesis more robust, still there are enough defeaters available that are plausible that those two arguments combined might not even be considered a particularly good grounding for the meta-empirical hypothesis that there's limitations, underdeterminations. So in Richard's view, the MI really plays a crucial role in grounding the success of those two arguments. So let's see. Right, so the idea is that MIA in this particular scientific context will lay the groundwork for the success of meta-empirical assessment in general as a valid form of assessment in that scientific context. Right, if you have a track record of meta-inductive success, that particularly with respect to these kinds of arguments, then we have some reason to expect that those arguments in this extended scientific context will be successful as well. So an example of this that Richard uses is like the success of meta-empirical arguments for the existence of the Higgs boson grounds future expectations of success in the particle physics paradigm in a meta-empirical way. So if we find, in other words, NAA, UEA arguments within the same paradigm for future developments of that theory, we can trust that those are more reasonable than in contexts where we don't have a track record of applying these arguments in a successful way. Okay, so it's sort of built on it. Now, Menon criticized the no alternatives argument in particular by trying to sort of set up an understanding of what kind of, in a Bayesian framework, what kind of prior probabilities can lead to non-negligible confirmation by the no alternatives argument. Okay, so in Bayesian confirmation, the normal view is that if you have a probability increase in the posterior from the prior, that represents confirmation. But it's always possible, of course, that that confirmation could be negligible. It could be so small as to be not really practically worth acknowledging or so. And so he made an argument that it's only in cases where we have artificially chosen prior probabilities, like fine-tuned or very particular prior probabilities, that we would have anything other than non-negligible confirmation by the no alternatives argument. So it's a clever criticism. So David wrote a response recently, it just came out, I think, not too long ago. And his response was to say, yeah, that's an interesting point, but it's not as artificial as it looks, in fact, to have prior probabilities that have this particular pattern. In fact, the kind of priors required for non-negligible confirmation for the NAA are exactly those that would be plausibly assumed in a successful research field. And that is where one where the meta-inductive argument is successful. And so in fact, the criticism supports the very point that Richard thinks is essential for understanding the role of the MIA as a ground for the other meta-empirical arguments. Okay? So it's an interesting interchange to look at, to see how the reasoning is meant to be sort of coherent and convergent. Okay, so now, this is really taking a lot of time, and there's still quite a few slides left, actually. But I think it's important to talk about the relation of meta-empirical and empirical confirmation. And here I think my remarks are maybe not as precise as they could be, but I want to sort of suggest the way that meta-empirical assessment is related to empirical confirmation. So first of all, so in the general sense of viability, not the specific one that I'll talk about soon, but the usefulness of meta-empirical confirmation or its applicability doesn't imply that it's a competitor to empirical confirmation. So in some situations, like quantum gravity, maybe like all we have are meta-empirical arguments available. But they actually are sort of should be understood to arise in this exact same contexts. Because meta-empirical and empirical evidence can cooperate, actually, to establish trust in scientific theories. The point, in a way, is that all along in the history of science, people have been making meta-empirical arguments, but they haven't really paid attention to the role they play, because basically empirical confirmation in the history of science has always been dominant and fairly decisive, and so you could just overlook that. It was so clear what the empirical results said that you could just rely on that. So in that sense, meta-empirical assessment is not really a novelty in itself in scientific methodology. The point is that it's always played this cooperative role here. It's just, it is a novelty in the sense that the key ideas haven't been formulated until recently, when they were put in a context where it was clear that we needed to think more carefully about the role of something like meta-empirical evidence and limitations to underdetermination. Okay? All right. I have a slide here about string theory. So I'm no expert in string theory, so I'm just saying what Richard says about the string theory case. So the basic scientific problem whose solution solved by string theorists is the extension of the paradigm of high-energy physics research to explain gravitational phenomena. Okay. And arguably, each of the meta-empirical arguments is applicable to string theory. After decades of work on the problem, the only viable solution produced is string theory. That's a no alternatives argument. Quantizing strings was attempted to solve the non-renormalizability problem of quantum gravity. But, you know, when we work out a string-based theory, we find that the graviton necessarily emerges in low energy limits, and also the Yang-Mills gauge theories, which is unexpected when we were trying to solve the gravitational problem. So there's a UEA argument that could be made. And then finally, the paradigmatic concepts and methods developed in particle physics during the 20th century not only yielded empirical success, but established the viability of meta-empirical arguments, like in the case of the Higgs boson. And so it looks like we have a meta-inductive argument that can support the application of other meta-empirical arguments within that paradigm. So that's just a kind of a short story about string theory, what Richard says about that, and the applicability of these arguments. A natural objection to the no alternatives argument for string theory is that there are alternatives to string theory. So some famous names making these counter-arguments, Smolin and Ravelli. They say there are other theories of quantum gravity, such as loop quantum gravity. So quoting Ravelli here, he says, in fact, not only do alternatives to string theory exist in the real world, but these alternatives are themselves considered credible by their supporters precisely because they themselves have no alternative under a different set of assumptions. And Smolin says, when expressed in terms of David's three non-empirical criteria, the success of loop quantum gravity as the unique correct approach to quantum gravity seems inevitable. So David had already sort of anticipated these objections in his book, but he responds to Smolin's particular objections in detail in another paper, recent one, 2022. So, you know, this is, again, I think, a better topic for discussion among ourselves, what the issue here is in quantum gravity. But I think I again get the feeling that some of these reactions are based, again, on an overly logical way of thinking of theories, that what we have is a set of assumptions that determine the content. Maybe we assume background dependence or unification or something like that, and on the basis of that limits underdetermination, and we can make no alternatives arguments or things like that. And that's not the sense in which the meta-empirical paradigm is meant to work. It's meant to be more like, okay, we're looking for explanations, theories that work in a certain empirical context. We develop theories. I mean, we're trying to solve certain scientific problems, let's say, that involve a certain empirical context. And then we go out there and do science and see what happens. We make meta-empirical observations. We try to interpret those observations in terms of arguments, either for a meta-empirical argument, or we consider one of the defeaters like more powerful, and then we see what consequences that has for our level of trust in the viability of the theory. So I think these counter-arguments depend instead on this kind of more logical paradigm, like, well, what we have are theoretical principles, we assume various of those, but that's sort of, thinking in a more I feel like a general logical way. We assume principles and then deduce things from that, rather than what I take to be a more empirical approach. We set a context, we go out and explore that context, see what happens, and then try to interpret the results. This is what I take to be the empirical approach to science to be all about. This is just now being done at the meta level. Okay, so so the significance of meta-empirical assessment, I think, would be somewhat precarious. It could only apply to speculative theories based on theoretical physics of the present. But David has maintained, at least since the book, probably before, but also in more recent papers where he's gone into it in more detail, that meta-empirical assessment is crucial for the very success of empirical assessment. And this has been explored through a number of case studies. One that he likes particularly is late 19th and early 20th century atomism. He thinks the success of atomism depended on meta-empirical arguments. He considers paleontology very briefly in the book. There have been several papers now about cosmology, both by him and me in collaboration, also about Mond, and inflation, especially a covering paper by us. William Wolff has written a paper about this, and it's applied in astrophysics in a couple unusual cases, like the Oumuamua asteroid, or I'm not sure what they decided it was, by Matarese. So I think more of these kinds of case studies are helpful to understand how meta-empirical argumentation could be applied in the history of physics. And to try to explain the role that Meta-empirical arguments play in empirical confirmation, I think I just have a few things to say about that. So if we go back to the canonical paradigm of theory assessment, where we just think about empirical confirmation as either evidence confirms or disconfirms a theory, then according to that paradigm, the sole reason to trust a theory is that its predictions are empirically confirmed. Okay, but as said earlier in the general argument I gave, without any argument that underdetermination is limited, one in fact has no reason to expect that an empirically confirmed theory is in fact trustworthy, because there's potentially an infinity of alternatives that diverge arbitrarily in future predictions. Even on ones that have been empirically confirmed in the past, there's no reason to expect that they'll hold in the future. Okay, so so now to connect this to empiricism and realism, I don't think empiricists, in the sense of empiricism held in the canonical paradigm of theory assessment, I don't think empiricists have offered a compelling reason for our, so to speak, habit, using like Humean kind of terms here, habit of trusting theories that hitherto have been successful. You can look, I think, the one that comes most to mind because of its vividness is von Frossen talking about, theories coming to the world, red and tooth and nail, and so on, in the kind of Darwinian explanation. But that doesn't really overcome this problem. It just sort of says, well, things evolve, things happen, but we have no reason to explain the success of theories. They just are, right? So I don't think empiricism is a kind of backwards-looking kind of point of view on the world when restricted to just empirical observations, I think. So then, in response to this, to try to explain scientific successes, realists respond by grounding trust on truth or approximate truth. Right? Science is successful because we're getting closer to the truth in some way. But there's a massive chasm, I think, between the empirical adequacy favored by empiricists and metaphysical truth. In a way, though, both of them depend on truth, this kind of context-free notion of truth. It's just empiricists restrict it to observable things, and realists are willing to extend truth to theoretical objects as well. Okay, so now I talk about viability. So David thinks that we need to avoid truth talk when thinking about theory assessment because of its sort of context, the context freeness of truth. We can avoid this really classical dilemma in philosophy of science between empiricism and realism by just sort of saying, maybe for philosophers there's an interest in the role of truth and maybe we also for philosophical reasons, for skeptical reasons or something, might want to withhold assent to certain beliefs or so. But that's not really sort of relevant to doing the practice of physics or science more generally. Okay, so viability is something introduced to sort of avoid this dilemma, I guess, a third kind of way. So strictly speaking, when David gives a definition of it, he says viability here is defined as the agreement of the theory's predictions with all empirical data that can be possibly collected within a given regime of empirical testing or empirical context. Okay? Now, when he says something like this, I suppose it reminds people a lot of the empiricist concept of empirical adequacy, much advocated by von Frossen. But I think it's important to distinguish these two concepts. So the epistemic significance of viability is meant to be different. It really is meant to be integrated with this whole paradigm of thinking about theory assessment that I've been talking about. But one sort of quick comment I can make about it is that it's different because it pertains to untested empirical contexts as well as tested ones. Right? We can talk about empirical valuability in future theories as well. We don't have to limit ourselves to empirical adequacy, the things that we've already seen or could have seen given what we expected.
So how is that different from a strong concept of empirical adequacy? I mean, this is a traditional distinction that's been made in the philosophy of science literature about the sort of weakly empirically equivalent or weak empirical adequacy, which concerns all the data or observations collected so far to this point or to some point.
Yeah.
Whereas the strong version of that is just for every possible kind of data or observation.
Yeah, sure. So then
to me, viability sounds like a strong form of empirical adequacy then.
Right. So then I want to kind of distinguish it based on the sort of paradigm of assessment that we're using, and that's the last point here. So I think viability gives us a scientific methodological concept of theory evaluation, right? Because it's embedded, it's a concept that falls within the scope of meta-empirical assessment. It's used in this context, whereas it's meant to distance itself from the philosophical concept of truth as correspondence, which is favored by empiricists and realists alike. Right? Empiricists want to say, well, empirical adequacy is the right criterion for assessing theories because we are sure that the empirically adequate theories have the right kind of truth content. Right? Their truth content is based on the stuff that we can take to be true, the observations. Yeah. Whereas realists want to say, no, we also agree that truth is correspondence, but we think that we can legitimately infer beyond just the empirical observations as being true. Yeah, I don't know. Maybe, I mean, you can think of them as closer related, but I think that, I kind of think like your talk a little bit yesterday, like the meta-B theory as a stance or something like this it's like taking a step away and saying, well, we're not really concerned too much with whether we should judge things from the point of view of empirical adequacy or truth full stop or approximate truth. Those kind of considerations and philosophical considerations don't come into theory assessment, I think, is what we want to say. And viability is just the term we use to avoid committing ourselves to debates that don't have anything to do with the methodology being advocated here.
Yeah, I still don't see how it's not a strong form of empirical adequacy.
Yeah, maybe it's not so bad to think of it that way. I mean, like the meta-empirical, in a way it's an empiricist-inspired methodological point of view too, because we're talking about meta-empirical observations that you could regard as a kind of empirical adequacy too at the meta level. So I don't know if it's necessarily so bad. Yeah. So.
Okay.
So maybe it's not so bad. I don't know. Maybe that's something we can discuss further. But yeah, I feel like when we start talking about empirical adequacy, that automatically shunts us into certain kinds of debates that I think are more metaphysical than they are methodological. But maybe it's harmless. I don't know. Okay. I think I'm going to skip that side, and just in the interest of time.
Yeah, we kind of are running up.
Yeah.
Against the time.
Okay. So I think I'll just say, I think this slide maybe is a little bit relevant. So another way to try to see the essential role of meta-empirical assessment in empirical confirmation is in reference to standard Bayesian confirmation, where we have degree of confirmation. If underdetermination is unlimited, then empirical confirmation is actually just useless for increasing credences. For any empirical confirmation will yield a negligible increase in posterior probability given the unlimited underdetermination. Right? If there's an infinity of theories, then there's just no way to confirm a theory, basically. It's almost like a mathematical point. So, in a way, Bayesian confirmation is actually kind of a nice framework because it makes it clear that confirmation depends on likelihoods and priors of alternative theories. So we do have to consider alternative theories. But how can we know what the space of alternative theories is without making some kind of extra empirical arguments? Meta-empirical arguments is what we think are relevant here for establishing an objective basis for the existence of limitations of underdetermination that can lead to generating any substantial, non-negligible confirmation of credences of theory. Okay, so this is a problem with Bayesian confirmation. I think in general, as a tool for assessing confirmation, you need to know what the space of alternative possibilities are. How do you know what the space of alternative possibilities are? Do you just make it up? No, you need some arguments to tell you, this is the space that's relevant for this context. So I don't know if that's all that compelling, but it just links to some work I did on my own. So we think, this has more to do with what Richard said in the book, but in general, meta-empirical assessment should be applicable to any conception of empirical methodology and science. So the Bayesian formulation is one, but people have discussed the role of limitative reasoning through the history of science, and that was the topic of my 2021 paper. So eliminative reasoning is described as this two-step process. You construct a space of possibilities, use observations to eliminate alternatives in that space. The Bayesian framework actually fits within this fairly well, depending on how you want to understand it, I guess. So evidently this second step can be understood as a kind of empirical confirmation, maybe even Bayesian confirmation. But what justifies the first step? So when I looked at what philosophers have said about justifying this first step, they say things like, well, we just assume that the space of theories has generality, or that we only include the uncontroversial ones. But I think these are inadequate as scientific justifications. At best, they're heuristic. And so we don't have a really good scientific justification for the whole process of eliminative reasoning without, I think, making some argument that's based on evidence. In this case, it would have to be meta-empirical evidence that we've picked a good or the right space of possibilities. And the problem is, if we just make these kind of heuristic justifications, then we run into obvious problems, like the kind of problems with interest to the best explanation. We might just pick a set that includes a bad, that is instead just a bad lot, and so the method only gives us the best of a bad lot. So I think we need to rely on evidential reasoning to secure justification at this first step, and it's meta-empirical evidence that I think does this. I guess I went through the last bit fairly quickly, but in the interest of time, I think we should wrap it up here. And I just have a couple slides extra that include these are papers I've written that are related to meta-empirical assessment, and these are the ones that I made use of, and most of the important ones I think that Richard has written on the topic. Okay, so that's it. Thank you.
I have a question we haven't really addressed, and I'm not sure we have the time to fully discuss it, but one thing that I'm a little bit uncertain I understand in this, David McCoy way of thinking about theory assessment is what it means to trust the theory. I mean, there's many ways in which I trust string theory. I trust string theorists to have done their maths correctly, that the theorems they proved are really theorems. I trust them that they're, working honestly to extend principles into domains of higher energy. I trust them in many ways. I distrust them in many other ways, in the sense that I would not bet money on them being right. I wouldn't trust my life on them being right, not at all, far from it.
So I think it's just a bit of jargon here in this
so
context.
what exactly is it?
So if we're thinking of things in a realist way, we'll talk about belief in the truth of a theory. And what we do is we replace this with trust in the viability of a theory.
Trust in the viability of the theory.
And then viability, of course.
Is that something like the credence that the theory is going to be empirically adequate for any possible kind of data you collect in this given domain?
That's it.
Okay.
I mean, it has the kind of connotation, the right kind of connotation that that theory is not just empirically adequate so far, but will be in the future in relevant contexts. But that's consistent with how you wanted to use the term empirical adequacy before. So the trust is sort of like, I know that this theory is a good one and will be, and I also trust that maybe the paradigm will be successful in the future when confronted with new conceptual problems in new empirical contexts. So trust has that kind of connotation, whereas belief seems just it seems a little bit flatter in the way that truth, like this, context-free idea of truth or something like this. And so if we talked about, belief in the viability of theory, it would be smuggling truth back into the story in a way that I think is unhelpful. But
Okay.
if you have, it's terminological though. I don't think there's anything more to it than that. Maybe Richard would answer differently, but I think that's pretty much it.
I probably have a very different conception of truth also than you and Richard have.
Okay.
Because, just for the record, I think that Newtonian physics is true.
Mm-hmm.
I mean, now that statement comes with a footnote, which is important, in its domain of applicability to a very good approximation.
Yeah.
Some sort of, wiggle clauses like this, I mean, of course. But with these wiggle clauses, I'm fine to call it true.
But there's forces.
Yeah.
But there's not forces.
No, it's true to that.
That sounds contradictory now. Yeah.
Meaning it doesn't quite get everything right, but it gets some aspects perfectly right to
So-
some really good approximation.
So then we say viable instead for that. To avoid, philosophical arguments that you can't have a contextualized truth. If you say, no, you can, but you have to think about it in this way, then of course you can use words like you like. So I think Richard refers to sort of, let's introduce a different word to avoid, really entrenched conceptions of what truth is. But fair enough, then that fits.
That's helpful, thank you.
Why does truth even come in here? Isn't it all about empirical adequacy? And also, once you talk about confirmation, don't you always want to talk about the strong notion of empirical adequacy, right? Because somehow, of course, it's empirical adequate if you make some observations, by definition, so to speak, that you want to use the observation to boost something, right? At least the base.
Yeah.
So that's it. I'm wondering, why is it even talk about truth in this thing? Why not? Sorry, viability. How can viability replace truth now? Does viability mean empirical adequacy in this wider sense? Or forces. You were mentioning forces. To what extent are forces? Whether we think of things as forces relevant, or also with unexplained coherence. To what extent are conceptual problems important? Maybe just more clearly put, is this now a program about confirmation with respect to empirical adequacy, strongly construed, or is this even more? Is it also about conceptual truth, which somehow is, so I'm wondering about.
I could just say, no, it's about viability, to avoid confusing philosophical issues about truth and so on. But I guess it sounds a bit more like the former.
But the viability got defined at some point as, you can agree with Chris, as empirical adequacy, right, broadly construed. But this has nothing to do with forces, for instance, right? The concept of forces, is this true or not, right? But then you said somehow, sorry, I don't want to annoy you, but then you somehow said viability also captures this element of whether forces are part of this regime or not, right? So that sounds as if viability is even much more than empirical adequacy broadly construed, right?
So I think to try to work out the terminology here, so a very, a stricter empiricist would say that Newtonian theory is empirically adequate within some context. What's true are the observations that we have. We wouldn't say the theory is true. We wouldn't say that there are forces per se, but maybe we would on an extended notion of truth or so. But here we can just say that forces are viable, all those observations are empirically adequate. It's terminological to some extent, but when you say, are forces true, that's going to bring in a whole host of questions that might confuse what this framework is about. This framework is just about.
So when you say forces are viable, in the sense that basically the theories which work with which work with this notion of forces, they are viable / empirically adequate broadly construed. So it's kind of a broad. In that sense. Okay, I see.
That's why I said it's kind of like a third way. We're not saying that theories are true there, but we're not just saying they're merely empirically adequate either, I guess, because empirical adequacy suggests a kind of philosophical program in a way, I think. So, rather than saying we're just empiricists, I mean, empiricists generally are fairly skeptical, I think, about things like meta-empirical assessment. And so, clearly we're not doing just very strict empiricism, but it is an empiricism-friendly kind of point of view, but it's one that expands the notion of what counts as empirical evidence. And meta-empirical evidence is evidence too, because it functions like evidence.
But you could also be hardcore meta-empiricist, right? You could be...
Okay. Yeah.
That's not how it's meant.
Yeah, I don't know exactly what Richard thinks about that, but I think I'm willing to be, and I think he is too, for the most part, being willing to be agnostic for most purposes. It's a separate issue then to go into philosophical questions about truth, and maybe that's a debate we want to have, but we don't have to if we want to understand the relevance and applicability of meta-empirical theory assessment.
Yeah, sure, that makes sense. Yeah.
Super question. Can two competent theory be both viable?
Yeah, of course, I think so. I mean, yes. I think, yeah, right. Yeah, well, maybe that's another difference too, right? It's like a realist would have to say one of them is true and one of them is false. Well, as far as we know, we don't know. We just have what we have in that historical context. So I think, yeah, that's a good point to bring up.
We're really running behind schedule, and I suggest, I think, that we make a break.
I think so.
Thank you very much.
Thank you.